Hi everyone, my name is Fabio Santos. I'm here today to present the article Can I Solve It? Identify APIs required to complete open source software tasks. The open source software community relies on contributions. However, many barriers exist until a new contributor can truly help the communities posting a contribution. One barrier is how to find an issue to start. It's hard to discover the range of skills needed to solve the issues, only reading the information available on the issue page. This study tries to help new contributors find an issue. Our research problem is, in open source projects, it's hard to find an issue to start due to the complexity to determine the required skills. The evidence are the big number of open issues in important projects and the fact contributors don't last so much. As the APIs used in source code provide valuable information about the skills needed, we claim if the contributors would be aware of those APIs, they could match their skills with the open issues. In this study, we investigate the possibility of automatically labeling the issues using API domain labels, high-level groups of APIs. Our study has two research questions. Number one, investigates to what extent we are able to predict the APIs will be present in the code that fixes an open issue. Number two, investigates the relevancy of the API domain labels to new contributors. We also have two goals. The goals aim to identify the best setup to predict the labels and to verify the relevancy of the API domain label. To answer these questions, we run a case study with the following method. In phase one, we mined a GitHub project called JABREF and parsed the source code looking for the important comments. In phase two, we aim to discover the best setup for our classifier based on the corpus number of grams used in IFIDF and machine learning algorithms. Finally, in phase three, we used a user experiment to discover whether the API domain labels are relevant or not. After running phase 1 and 2, we got the metrics for the possible setups. For the corpus, as you can see, the three last options are statistically tied and had better results than title. For the number of grams, unigrams clearly outperformed the other grams options. The random forest algorithm outperformed all algorithms. The MLP classifier had good recall, but we found a statistical difference in precision and definition. After running the user study in phase 3, looking to the plots, titles, labels, and bodies were the most selected regions used to decide which issues to contribute. API domain labels increased the perception about the label's relevancy. From the results of labels relevancy, we divide the labels in three types: API domain, code component, and issue type. Code components are labels indicating in what model the issue is located. Issue types are more generic labels that classify the labels into buggy, future improvement, or good first issue, for instance. API domain labels are found more relevant than the code components, while API domain labels and issue type labels were statistically tied. API domain labels were more relevant to developers from industry and speed-based coders. As conclusion, we claim the best configuration is random forest algorithm with unigrams and body as corpus. We consider the body as the best option. Since the body is smaller and had statistically similar results, the results suggest the API domain labels relevancy even more when the participant is more experienced as coder. Thanks.